Thank you for your interest in StratiSystem, the infrastructure operating system for storage, compute, virtualization, AI, and HPC architectures. In this video, I will cover the basic VM and cluster storage functionality within StratiSystem. For a deeper dive into more advanced platform capabilities and use cases, see the Advanced Functions playlist on our YouTube channel. We will start by logging into the web-based management interface located at https:// any IP address in the cluster on port 3199. After login, the main cluster management console is displayed. In this scenario, both storage services, known as StratiStore, and hypervisor services, known as StratiSERV, are enabled on the platform. Together, these capabilities form what we refer to as HyperServe, a fully functional hyperconverged platform that delivers integrated storage and compute services across the cluster. Before we begin, I'll cover a few important high-level platform topics. As you can see, we are logged into the first node of the cluster. From here, administrators have access to both node-level and cluster-level management areas. If you log into another node, the same view and functionality are available there as well. The StratiSystem management layer is fully distributed and accessible from every node in the cluster. You can use the node selector in the upper left corner to change which node you are viewing, or you can simply access the management interface through another node's URL. Either way, the administrative experience, visibility, and capabilities remain the same across the cluster. The interface was designed to feel familiar and intuitive for operators with experience using other virtualization platforms. Each object within the interface includes a corresponding action button that opens a context menu with the relevant actions available for that object. This keeps common administrative tasks easy to find and consistent across the platform. In the Hosts and VMs tab within the StratiSERV Manager, the cluster hosts are displayed in the top pane, while the cluster virtual machines are displayed in the bottom pane. Host-related actions can be found under the Action button located on the far right of the cluster hosts table. Actions such as changing host-level networking capabilities such as enabling SRIOV, enabling virtual GPU acceleration support, and maintenance mode operations can be found within the Host Context Action menu. In the Cluster Virtual Machines table, you will see the manifest of all VMs across all hosts within the cluster. Similar to the Hosts table, there is a corresponding action button for each VM in the VM table. The first action we will explore is the Power On function. Simply click on the action button for the VM you wish to power on. Select Power from the menu. This will open a modal window displaying the available power operations for this specific VM. Here, I will select Power On and press the Confirm button to apply the operation. The next action we will explore is opening the Remote Console. Using the same action menu, select Remote Console. Immediately, a detached Remote Console window will appear showing the current live state of the VM. The next action we will explore is the Migrate VM function. StratiSystem supports both offline and live migration of VMs to any host in the cluster. Here, I will show migrating a VM from host 1 to host 2. The next action we will explore is the Virtual Disk Migration function. StratiSystem supports both offline and live disk migration for virtual machines, allowing VM disks to be moved to any available storage location in the cluster. This can include storage within StratiStore, any external third-party storage array, SMB, NFS, an S3-compatible cloud-backed storage repository, or other supported cloud storage technologies. The next action I'll cover is enabling high availability, or HA, for a virtual machine. HA is enabled on a per-VM basis, giving operators granular control over which workloads are protected. When HA is enabled, the VM is protected against events such as host failure. For example, if an HA-enabled VM is running on a host that fails for any reason, the cluster detects the failure and automatically restarts the VM on another surviving cluster member so normal operations can resume. Recovery typically occurs within 30 to 45 seconds from the time of failure. The next action is the Remove VM option. This function includes two available sub-actions. The first is to unregister the VM from inventory. This is non-destructive and only removes the VM from the cluster manifest. The second option is to delete the VM entirely. This is a destructive action and requires confirmation before proceeding. The next action is the Edit VM Settings option. This section provides access to auxiliary VM configuration options, such as enabling guest channel support, which is enabled by default, high-resolution display support, and confidential computing support. Confidential computing support is available when the underlying host hardware supports the required processor capabilities, such as Intel TDX or AMD SEV. The next action I'll cover is the Virtual Disk Format Conversion option. This feature allows operators to convert VM disks to and from supported formats as often as needed. StratiSYSTEM supports converting from the native QCOW2 format to RAW, VHD, VHDX, VMDK, and native block formats. RAW and RBD formats convert the VM disk in place, while VHD, VHDX, and VMDK conversions create a copy of the VM image in the selected format for use with other platforms. The RBD block conversion is similar to using raw device mappings, providing direct block-level access to the storage cluster without relying on a file system. The next action I'll cover is the Clone VM option. As the name implies, this feature creates a copy of an existing virtual machine. The Clone VM can then be used for a variety of purposes, such as testing, development, backup validation, template creation, or rapidly deploying additional workloads within the system. The next action is the Resize Virtual Disk option. This pane displays all attached virtual disks along with their current sizes. To resize a disk, simply select the desired disk, enter a larger size value, and click the Confirm button. The next action is the Convert to Template option. This action marks the selected VM as a template, removing it from the standard VM inventory and placing it in the template inventory. Before converting a VM to a template, it is recommended that the operator run a sysprep process within the guest operating system. This helps ensure that each VM deployed from the template is unique and avoids potential conflicts such as duplicate hostnames, machine IDs, or network identifiers. To deploy a VM from a template, select the Deploy from Template option from the Template Action menu. Enter a unique name for the new virtual machine, then click the Deploy button to create the VM from the selected template. The next tab is the Containers tab. This provides access to the Global Container Management interface, allowing operators to manage the local Kubernetes cluster within StratiSYSTEM, Docker, and Podman container environments across the private network, and container services running on public cloud platforms globally. The next tab is the Performance tab. This provides a cluster-wide real-time performance summary of all 4 core metrics: CPU, memory, network, and storage. For even more performance insights, the Operations panel provides much more performance detail and long-term trending analysis. We'll review the Operations panel later in this video. Additionally, within the Performance tab is the Distributed Resource Scheduler settings. This can be found by clicking on the green eye at the top of the pane. The Resource Scheduler allows the operator to define CPU and memory utilization thresholds. When those thresholds are exceeded, the cluster will attempt to rebalance workloads across the available physical hosts. This helps prevent any single host from becoming overloaded from a CPU or memory perspective. The next tab is the Shared Disks tab. This provides support for external third-party block storage arrays, such as iSCSI, Fibre Channel, or any other shared block storage technologies. This allows a centralized storage device to be shared across all hosts within the cluster. When a new shared disk file system is created, it is automatically registered as a VM storage pool. This storage pool can then be used for VM workloads or for any other data set the operator chooses to place on the file system. The next action I'll demonstrate is the use of affinity and anti-affinity groups. Affinity groups are used when you want specific VMs to remain together on the same host, while anti-affinity groups are used when you want specific VMs to remain separated across different hosts. As soon as the group is defined with 2 or more VMs, the rule takes effect. The cluster will then move the VMs as needed to satisfy the defined affinity or anti-affinity requirement. The next action I'll demonstrate is configuring the platform for VM backups. The first step is to define at least one backup repository. A backup repository can be any storage location visible to the cluster, including StratiSTOR storage, shared disk storage, SMB, NFS, an S3 compatible cloud-backed storage repository, or other supported cloud storage technologies. When at least one backup repository exists, the interface allows you to define a backup job. Do this by clicking on the Add Job button in the upper right-hand corner. From the New Backup Job view, you can provide a name for the backup job. Select the VMs that will be protected by the job, define the backup schedule, configure retention time frames, and set additional options such as pruning controls and job notifications. Now that the backup job has been defined, you can execute it immediately or wait for the scheduler to run it. Once the backup is complete, it will be visible in the backup pane. To view the backup details, expand the job by clicking the greater than symbols until you reach the virtual disk level. At that level, the interface displays details such as the disk name, disk format, backup date, virtual size, and the actual data size of the backup. There are also options to perform a checksum validation of the backup, as well as the ability to restore the VM under various conditions. In the Restore pane, you can choose to either restore to alternate VM, which is the default, restore over the existing original VM, or simply restore the VM definition. I will perform a restoration to an alternate VM, which is preferred as it preserves the existing VM state and definition. Once the restore is complete, it will appear in the VM inventory under Cluster Virtual Machines. VM backups are conducted using change block tracking. That means that while all backups are considered full backups, the actual size of the backup is only representative of block changes that have occurred since the last backup. This makes consecutive backup storage efficient and fast, which is also highly beneficial for cloud-backed repository locations. Next, we'll cover VM replication. StratiSystem supports replicating VMs to another StratiSystem platform or any other platform, whether it be a public or private cloud. To enable replication for a VM, you must first define a destination as the recipient for the replication data. Once a destination is defined, the next step is to create a replication job. The job controls the replication schedule and transmission options. The last tab in the StratiSERV Manager is the import function. StratiSystem provides support for migrating existing VMware or Microsoft Hyper-V VMs directly into the StratiSystem platform. All that is required is to authenticate to either the VMware or Microsoft environment. Once authenticated, the available VMs that can be migrated will appear in the table. From there, click the Action button to import the selected VM into StratiSystem. The source VM is not altered during this process. StratiSystem copies and converts the VM data, then inserts the required VM tools and drivers. Once the import process is complete, the operator can power on the VM within the StratiSystem platform. Next, we will move to the StratiSTOR Manager to review the storage cluster-related functions. The Cluster Status tab displays the current status of cluster services, along with any relevant warnings, notices, or health-related messages. Next, the Block Services tab allows the operator to create block pools and block devices from those pools. This is useful in several scenarios, such as serving iSCSI or NVMe-based disks to the network, mapping block devices directly to virtual machines, or presenting block devices to local StratiSTOR hosts for use with ZFS file systems. Next, the File System tab allows operators to create distributed file systems for a wide range of data sets. It also supports creating subvolumes, which are required for advanced storage-based snapshot functionality. In addition, the file system can be mapped to the hypervisor on each host as a VM storage pool for storing virtual machine image files. Additionally, when file system protocols such as SMB are enabled, the file system can be made accessible across the local area network using the SMB protocol. This allows any SMB-enabled system to access the file system data. The platform also supports Active Directory integration for environments where an AD domain is present. In this screen, you can define SMB groups and users and create or edit SMB shares. The next tab is the ZFS Services tab. Any block disk device visible to the system can be used with ZFS, including supported cloud-backed storage targets such as S3. To create a cloud-backed block device using S3, first define the service provider along with the necessary security keys. Next, define the service provider connection. A connection needs to be defined for each S3 bucket that will become the block device in the ZFS pool. To create a ZFS pool, the operator provides a pool name, RAID level, mount point, and any additional options such as encryption, compression, deduplication, checksum protection, auto-trim, and auto-replace. More advanced CFS-related storage functions will be covered in detail in a separate video. The next tab is the Web Services tab. Web Services allows an operator to share access to any file system on the cluster to external web-based users. It also provides role-based access control as well as anonymous shared link access. The next tab is the Operations tab. This area provides access to platform operations, performance trending and analysis, and event workflow-related functions, which will be covered in more detail in a separate video. The next tab is the Support tab. This feature allows SteelDome support personnel to securely access the cluster for support purposes without requiring firewall changes, a jump box, or additional remote support software. The operator can enable remote support when assistance is needed and disable it once the support session is complete. The final tab is the Update tab. This provides a one-button upgrade function for the entire StratiSystem cluster. When updates are available, this process upgrades the API, management modules, and Web UI to the latest version. The update process is non-disruptive and can be performed at any time, as often as needed. This concludes the basic VM and cluster storage overview within StratiSystem. For more information related to SteelDome technologies, please visit our website at steeldome.com. Additionally, visit our YouTube page for more StratiSystem walkthroughs and advanced deployment use case videos.